Hi all, welcome to my talk, Evolving TDD, Moving Past Simple Example Tests. So a little bit about me to start with. My name's David Sarginson, as I've said. I've been writing code for about 20 years now, and arguably I've been writing good code for about the last 8, I would think. I'm very proud to be a STEM ambassador and also a trustee and organizer for the Tech for Kids charity that tries to get kids between the ages of 6 and 16 interested in the STEM subjects by putting on hands-on tutorials and digital maker parties where they can build robots and program Minecraft till their hearts are content. I'm also currently the head of software development practice at Opencast, which is brilliant because I get to work with lots of amazing people and help them write good software. Just before I start the rest of the conversation, I'm gonna make a big assumption here. We all do TDD and we all do it all of the time. Now, I'm sure if we can all accept Wolverine dancing for 2 hours in The Greatest Showman, we can do this for TDD for 20 minutes. I think TDD is a good value proposition. The amount of value that it derives is much, much greater than the actual additional effort in typing that it costs. Okay, moving on. So in this session, I'm going to cover kind of 3 main topics. Everybody will be very pleased to hear, no doubt, that you can't have a talk about unit testing or TDD that doesn't have the word coverage in it. And I'm very pleased to report this is the only place you'll see the word coverage in the rest of the talk, because as everybody knows, if you're test driving your code, that coverage becomes a meaningless statistic. Every line of code you write is tested. So what I want to cover is evolving the way we think about TDD. It's been around a long time now. And obviously, evolution is one of those things where we try new things, and if it doesn't work, we try something else. So this is about how I now think about TDD, about how I put it into my software development workflow. I'm also going to introduce probably some of you to property-based testing and show you how I fitted that into my workflow again. And a couple of tools that will help you do property-based testing kind of regardless of the language that you're currently writing software with. And ultimately, I want everybody to write better code and have more confidence in getting it delivered. So if we think about textbook TDD, I'm pretty sure most people here will have this image indelibly burned into their memory. We write a failing example test. We then make it pass in the simplest possible way. And then we refactor out any duplication or back to a better pattern or make your code simpler. Yeah, this is great. And it's a very good starting point. And you know, about 10 or 15 years ago, even this is kind of where TDD was. Unfortunately, that's kind of all TDD that, you know, the book says on the subject. What to test and how to test it and how many tests you need to write always kind of come down to the individual developer. And that's the bit that I've really been thinking about the last, as I've said, kind of 8 years of writing good code, how we can make that even better. One of the problems we have is how many tests to write. This really drives me on to my next point, which is that evolving the thought of what TDD is and what it actually means. Again, I'm sure you may have seen this before. The example of test-driven development, I think, is maybe the wrong phrase. It should be test-driven design, because what we're really trying to do is drive out good design in our code by writing tests first. And what I mean by this is, before we even write a method signature, we should really think about the inputs to that function. Should I pass it a list of things? Should I just pass it an individual thing? Do I then just use, you know, my language's functional programming concepts to map over that list and just pass this function in as the function in the map reduce? Really think about the outputs of a function. If I'm just returning a Boolean yes or no as part of a function, is that Is that useful? Is it reusable? Or given a function, if I return an object, is that more useful? Because I can then chain methods together with that object and pass it further along. And naming, as everybody says, naming is one of the most difficult things a software developer has to do. And you know, I'm obviously not going to give you a great deal of help with that point in this talk. But these are the things that we really want to think about when we talk about evolving TDD. It's about designing your code. It's about putting in the thought work that actually makes your code better. Chris Howe Jones, who's a sponsor of the conference and we'll be talking again today, and also a mentor of mine, he constantly reminds me that TDD is about fast feedback loops. It's about trying something out and getting that feedback, whether or not it works or doesn't work, as fast as possible. So if it doesn't work, you can just move on with something else that's even better. That's thinking about TDD. I'm sure a lot of you know about property-based testing. Again, this is one of the things that's been out for a number of years now, but doesn't seem to have reached kind of mainstream. You know, there's not a great deal of property-based testing out there based on some of the code bases that I've seen recently in lots of different areas, from banking to private sector. I'm not saying there's not, just from not what I've seen. So what is property-based testing? As we mentioned before in TDD, you create an example test, which is, given this particular input, what is the particular output that I would expect to see? Property-based testing allows us to go one stage further. And with the rise of functional programming and pure functions, we only really now have to worry about the inputs to a function and the outputs of a function. We try and move away from having to create a really big stateful starting point and mock out lots of different dependencies. If we have a function which takes an input and provides an output as a pure function, property-based testing, it comes all into its own. What we want to do is we want to create a generator, and that generator can create us arbitrary values for the input of our function, yeah, be it strings or complex objects. Yeah, a lot of the tools that I show you next, they have built-in support for primitive types. If I want a function which takes a list of integers or takes an integer, that's already baked in. I just ask the generators to give me that. Or I just create my own complex type ones by just basically compiling and putting generators together. So what do we do by that? Once I've generated all of my inputs, I get my tests run. And obviously, if I generate 100 inputs, I'm going to run 100 tests. Yeah, that's much more efficient than me coming up with 100 example tests and having to run them all through individually. And it's also a lot less code. The other real benefit that we get from property-based testing is this concept of shrinking the input. So if my function takes a string, it may be that my generated input is 100 characters, and it's not even standard characters that I could put in through my keyboard. Because it's defined as a string, in most languages, that could be any character that can be represented within a string. So, you know, Chinese characters, non-printing characters, all of those kind of things. If that's an incredibly complex 100-character string that fails, what my property testing framework can do, it can shrink that input by constantly trying a simpler input to see if it still returns the same error. And what I get back might be a string of 2 characters that makes the test fail, which is then much easier for me to start debugging what the problem was. Once we've got that failing input, we then verify the output against either a specific property, or sometimes they're called invariants. So what do I mean by that? So idempotency. So if I have a function which sorts a list, which is the classic example, if I sort that list twice, that should still be the same as if I'd sorted it once. And I can compare the two together as my assertion statement. And again, I get my property framework to generate me 100 different lists or 1,000 different lists of different values inside them, and they should always return the same answer to me. Symmetry, again, is a very powerful thing when we're doing encoding and decoding. If I'm writing a function to encode something or a function to decode something, what I can do is I can generate 100 inputs to my encode function, and I can encode the values. I can then run my decode value on that output and then verify that that's the same value as was put in. This has been used to great effect in libraries like Yoda Time and things like that, where people have found really obscure problems in the Yoda Time library by generating, thousands of different date values and then converting them one way and then back to see if it's actually a symmetrical transformation. So how do we fit this into the TDD workflow? Again, I'll just quickly mention the tooling that's available out there. So as it says there, most languages have property-based tools. There's Quick Check for Erlang and Haskell. I believe Quick Check was the original one for Erlang, which was quickly ported across to Haskell. Scala Check, JUnit Quick Check, Test Check for Closure, JS Check for JavaScript, and then FS Check for C#. I've used 4 of these libraries myself personally, and again, they're all pretty much the same. They generate you their inputs, they allow you to shrink the failing inputs into a manageable value, and then they allow you to create assertions on X number of different test cases, depending on how many you want to generate. JUnit Quick Check there is highlighted for Java, because that's the quick example that I'm going to go through now. So we'll see here that this is standard Java code. We're currently using the JUnit Quick Check runner to run this property-based test, because that will run this as many times as we configure it to. We're testing the Java string class for its property. We've defined a property test there, which is the concatenation length. And that test takes 2 string properties, string 1 and string 2. Now, because these are primitive types, JUnit Quick Check will generate them for me. And then we're basically asserting that if I use the plus method, the concatenate method, and join 2 strings together, the length should be the sum of those 2 values. And that's as simple as property-based testing can start with. And again, you can make this a lot more complicated depending on the types that you want to assert. So how do we fit this into TDD workflow? I thought this was absolutely brilliant, and I thought I'm going to do this everywhere. But what I did was I replaced all my example tests with property-based tests. But the problem was I found I was spending far too much time in the red to green phase instead of spinning around that very quick feedback loop to try things out and get a good response. That was a problem. But the power of property tests, I couldn't just let go just because it didn't quite fit. So what I tried to do was still drive out and go around that feedback loop very quickly with example tests to drive out the behavior of my functions that I wanted. But then as part of the refactor stage, what I wanted to do was then look back at all the example tests and see if an emerging property had appeared by all of the different tests, and then replace several of those example tests with one property test, which not only resulted in less code because there was less example tests, but also I could say, generate me 1,000 different input values and test this property. So my coverage, if you'd like, or the actual amount of testing that I was doing was going right up. So this is where I am currently now. I've evolved in my own head the practice of TDD. I think, what am I trying to do? What does this method have to do? How do I know when I've done it? And this is where I design my inputs, my process names, and my outputs. And I make sure they fit in with all of the rest of the code in the ecostructure where it runs. I then write that failing test, an example test, just to drive that forward in the quickest possible way. And then I can write just 1 line of code again, usually to make all of my remaining tests pass, to drive out that behavior. I then think, is this the simplest design that I could have? Can I replace any of the tests that I've just written with a property-based test to get more confidence in my code? And that's currently where I am. We think more because it's very easy to fall into the red-green refactor, red-green, red-green, red-green cycle and actually forget that writing good code takes thought. And finally, after we've been through all of that, there are no silver bullets, unfortunately, as one of my friends, David Gregory, said, who's a great functional programmer. There are no silver bullets. Following a methodology or anything like that, be it TDD, will not automatically generate good code. There are no frameworks out there to help you do that. It requires thought and effort. But by using property-based testing and constantly trying to push the limits of, any of the practices that we're currently using, TDD especially. What I'd like to get to a point is where everybody has, more confidence in the software that they release to production, because that's what's important at the end of the day. So thank you very much for your time in listening to me. And also thank you very much for the Build It Right organizers for giving me time to talk today. Thank you very much. Bye now.